We all know computers are absolute masters of logic, right? They can crush grandmasters at chess, they can solve equations we can't even comprehend, and they find tiny patterns in massive amounts of data. They are just amazing in worlds that have clear, defined rules. But what happens when the logic just runs out? What happens when there are no rules left to follow?
Well, that's when we humans tap into something else entirely. A hunch, a gut feeling. So it begs the question, what if an AI could do that too? What if we could teach it to have a hunch? That's the absolutely fascinating idea we're going to dig into today.
All right, so let's get right into it. To really get why an AI would even need a gut feeling, we first have to look at where the purely logical AI that we have today just hits a brick wall.
You can really think of this as two different modes of thinking. On one side, you have your logical AI. This is the world of traditional game theory, right? It's all about calculated moves, following the rules, operating with total certainty. I mean, think of an AI that has mastered chess. It is unbeatable inside that system. But what we're aiming for here is what's on the right, an intuitive AI. This is all about gut feelings, taking chances, and navigating complete uncertainty. It's really the difference between having a perfect rulebook and, well, having no rulebook at all.
So, okay, the big question is, how on earth do you teach a machine something so fundamentally human like a gut feeling? Well, some researchers came up with a pretty ingenious project to do exactly that.
First things first, let's get a clear definition of what we're talking about. The researchers define intuition as the ability to get knowledge without conscious reasoning, and that's the key part. See, intelligence is based on what we already know. Intuition, that's what we use to navigate the stuff we don't know. It's that gut feeling that kicks in when the logical path just isn't there.
The whole big idea here is actually pretty simple at its core. It's this. If you can describe something with math, you can probably teach it to a computer. So, these researchers built a game specifically designed to force people to rely on their intuition. The plan was to capture thousands of these human choices and then use them to build a mathematical model for an AI's gut.
Okay, let's talk about this game. Because it's not just any game, right? It's a purpose-built simulator. You could almost think of it as a device for capturing human intuition.
So, the main goal? Super simple. You're dropped into this little 16-box maze, and all you have to do is find the monster. You find it, you win. Easy enough.
But there's a little twist, of course. There's also gold hidden in the maze. Now, finding the gold gets you bonus points, but you don't have to get it. And this little detail? It introduces a very human factor into the mix: greed.
And here's where it gets really tricky. Out of the 16 squares on this board, 4 of them are pits. You fall into one, boom, game over. You lose instantly. Now, this crazy high risk of failure, that is totally on purpose. It's designed to strip away as much certainty as possible, forcing you to make moves that aren't based on pure logic.
Now, you're not going in completely blind. The game does give you some clues. If you feel a breeze, you know a pit is nearby. A smell means the monster is close. Glitter means gold. But here's the thing. Notice how vague that is? A breeze doesn't tell you which box has the pit. It could be one, it could be all of them next to you. So these hints, they guide you, but they almost never give you a 100% certain next move. You're always forced to take a bit of a leap of faith.
There's this quote from the research paper that just nails it. It says, "The simulator isn't just a game, it's the psychology of life scaled down to a 16-boxes maze." And that's so perfect, isn't it? It's a tiny model of life itself. We've got goals, we face risks, we get these little hints, but in the end, we often have to navigate pure uncertainty and just make a call.
Okay, so the researchers have collected thousands of these gameplay sessions. Now what? How does an AI actually use all this data? This is where it gets really cool, and we see how these human decision maps can help a computer solve problems that right now it just can't. So let's walk through a clear, real-world example they give. Imagine you've got an AI whose job is to identify animals in photos. It's looking at a picture, it's run through every single algorithm it has, checked all its databases, and it's totally stumped. It cannot figure out what it's looking at. It has hit a logical dead end. So, what happens next? Well, first, the AI recognizes, hey, I'm stuck. Then, instead of just giving up, it taps into this massive library of human decision maps. It might pick a map from a player who won the game by being, say, cautiously aggressive. Maybe that human player made 2 safe info-gathering moves and then took one massive all-or-nothing risk that paid off. The AI doesn't copy the game moves, it copies the pattern. So back to the photo problem, it might try 2 more safe processing methods, and when those fail, it takes its risky leap, maybe by applying a totally different, much less probable type of analysis. And boom,
That leap lets it break the stalemate and finally identify the animal correctly. And this is the really critical point to understand. The AI has no clue why the human made those choices in the game. It doesn't understand fear or greed or that feeling of I'm just going to go for it. It is simply borrowing a winning pattern for how to act when you're stuck. It's like a blueprint for what to do when logic fails you.
And the scale of this is just mind-boggling. That little 4x4 grid can generate more than 20 trillion unique game scenarios. I mean, to put that into perspective, that is thousands of times more layouts than there are stars in our entire galaxy. This creates a nearly infinite library of human decision-making, a gigantic collection of hunches for an AI to learn from.
So when you put it all together, what does this actually mean for the future of AI? Let's zoom out and look at the big picture here.
This quote from the lead researcher really wraps it all up. He said the goal isn't to improve an algorithm, but to add a brain that takes decisions where there are no other options left. Think about that. It's not about making the old brain faster. It's about adding a whole new one.
So, at the end of the day, this isn't about replacing logical AI. It's about complementing it. It's like this. Traditional AI has given us this incredibly powerful analytical left brain. This research is all about building a creative, risk-taking right brain to go with it, a brain powered by all of our human hunches. It's a tool for breaking through walls when the path forward is completely dark.
And that leaves us with this one final, pretty wild thought. If an AI can learn from the intuitive patterns of millions of our decisions, could it one day develop its own kind of gut feeling? And if it does, could that artificial intuition help us solve the kinds of huge scientific or creative problems that are currently just beyond us? It's a pretty powerful idea to chew on.